In this example, I'm going to use synthetic division to divide this polynomial that contains both rational and irrational coefficients by this linear binomial x minus the square root of 2. Well, remember, to use synthetic division, we need this divisor to be in the form x minus k, and it is x minus the square root of 2. So we know that the value of k is, well, the square root of 2. So I'm going to go ahead and put that value out front for my synthetic division, and I'm going to go ahead and draw my box here for my algorithm. And then let's go ahead and put all the coefficients in their place and make the columns. So the x cubed has a coefficient of 1. My x squared has a coefficient of 1 minus the square root of 2. My linear term here, this x, has a coefficient of negative 12 minus the square root of 2. And finally, my constant is 12 times the square root of 2. I'll go ahead and put my little box down here for my remainder, just in case there is one. Okay, so let's go ahead and do my synthetic approach now. So I'm going to bring down this leading coefficient of 1, and then I'm going to go through a series of multiplications and additions on these columns. So the square root of 2 times 1 is the square root of 2. So then when I add this column, the negative square root of 2 and the positive square root of 2 cancel, and I'm just left with 1. So when I multiply again, I'll have another positive square root of 2. And once again, when I add this column, the square roots of 2 will cancel, and I'll just have a negative 12. And then when I multiply, I'll have a negative 12 times the square root of 2, which when I add this column, they cancel out, and I get 0. All right, well, this isn't so bad at all. So I have my constant and my linear term and my quadratic term here. So when I build this quotient up, I'll have x squared plus x minus 12, and I had no remainder. So even though we had both rational and irrational values for coefficients and our constant over here, doing this division actually left me with a pretty nice polynomial, x squared plus x minus 12.